Why is NumPy Einsum so difficult to learn? Imagine trying to read a secret code that uses symbols instead of words. That's what working with NumPy's Einsum function can feel like. It's a powerful tool for tensor operations, but it can be tricky at first glance. The main reason is that Einsum uses Einstein summation notation, which is a compact way to describe complex calculations involving multidimensional arrays. This notation is not like regular math. It uses letters to label array axes and symbols to tell you how to combine or sum over those axes. For someone new, it can seem abstract and hard to visualize what's happening behind the scenes. Think about it this way. When you do simple matrix multiplication, you just multiply rows by columns. But with Einsum, you can do that and much more, like summing over multiple dimensions or transforming data in ways that are hard to express with normal functions. This requires you to think in terms of higher dimensional arrays, or tensors, which can be confusing if you're used to only two-dimensional matrices. Visualizing how these axes interact isn't straightforward, especially when working with 3, 4, or even more dimensions. Another challenge is that the syntax for Einsum is very precise. A small mistake in the string of labels or the order of axes can cause errors that are not always obvious. Since Einsum is so flexible, it doesn't always give clear feedback about what went wrong. Debugging can become a puzzle, especially if you're trying to optimize for performance or correctness. You might spend a lot of time tweaking the notation just right. Performance is also a factor. While Einsum can be faster than writing loops in Python, it depends heavily on how you specify the indices and the shape of your arrays. If you don't understand how the notation maps to the actual data, you might write an expression that works but isn't efficient. This can lead to slow computations or unnecessary memory use, which is a big deal in AI development where speed matters. In the world of artificial intelligence and data science, tensor operations are everywhere. Neural networks, attention mechanisms, and probabilistic models all relying on manipulating multidimensional data efficiently. Tools like ChatGPT, DALL, and Midjourney use complex tensor calculations to generate images, text, and more. Knowing how to use Einsum well allows developers to write concise code for these operations, saving time and reducing bugs. Practicing with Einsum helps you implement custom layers in neural networks or perform batch operations on large datasets. It's especially useful when standard functions don't fit your needs. But mastering it takes patience because you need to understand how to label axes correctly, visualize multidimensional data, and write error-free notation. Once you get the hang of it, Einsum becomes a powerful part of your toolkit for AI development and data science. So, to sum it up, NumPy's Einsum is tough to learn because it uses symbolic notation that's not intuitive at first. It demands a good grasp of tensor dimensions, careful syntax, and an understanding of how to optimize calculations. But with practice, it becomes an invaluable skill for creating efficient, flexible tensor operations in AI and data science projects.